Hello, mathematicians. This is Mr. Mailhot. Let's do some math. All right. This is page 13 in your packet for this week. We're going to look at some inequality word problems, which means we're going to use that race strategy that you have in your notebook about reading and annotating, crossing out, and using equations. And this time, we're not going to make an equation. We're going to make an inequality. So maybe we change it to RASI? I don't know. Same idea, though. First, though, they have us go through a couple review problems, and I think these are good because they're different than we've seen before, but you guys can understand them, and they'll help us get smarter. So draw the bars down around the inequality sign. For number 1, we'd subtract 21 on both sides. Bring down the 8x. 56 take away 21 is 35. Sign stays the same because we did not divide by a negative. We do need to divide, though. We got to divide by 8 because it's being multiplied by 8. Now 8 divided by 8 cancels out, and we're left with x. 35 divided by 8, though, that doesn't divide nicely, does it? I think, according to my calculator, that gives us 4.375. Now the sign stays the same because we didn't divide by a negative, but you guys, yeah, this is our answer here. Even though it's a decimal, that's fine. Think about what that means, though, over here. What's a number that's less than 4.375? Well, 4 is. 4 would be a solution. What's another number? What about 4.374? That's a little tiny bit less than 4.375. That's also a solution. It's less than 4.375. But if we thought about something like 4.376, is that less than or equal to 4.375? Nope. Doesn't work. What about the number itself, 4.375? Is that less than or equal to 4.375? Yeah, it's equal. So even decimals are fine. Let's do number 2. Here's why it's kind of new. Remember, we do need to distribute when you see something like this. Now, since you're not doing something to both sides, you're not actually changing the value of that side of the inequality. You're just multiplying through the parentheses. So this is still going to be 56. And over here, it's still a less than sign. We're going to have 49 minus 7x. It looks different. They're different numbers, but we didn't take anything away. Think about our bags and blocks from a while ago. We didn't take any blocks away. We just multiplied some stuff. Now we can solve pretty easy. Subtracting 49 on both sides. That cancels. 56 take away 49. I think that's just 7. Sign stays the same. We didn't divide by negative or multiply by negative, at least not yet. But look at our next step. Negative 7x on that side. Yeah, we got to divide by negative 7 on both sides, which means we end up with x. The sign flips, negative 1. Now you would say this in words, negative 1 is greater than x, but remember, when the variable is not first, we can always just flip it around again, just so it looks like all the other ones that we've been doing, and say x is less than negative 1. Cool. Those are good problems. I like those. We're going to keep going. Remember, you can pause and go back and rewatch and to copy down what you need, or just to listen again. That's always a good thing to do. Here's what we're going to do for these problems. I think there's 4 of them. It says to choose the inequality that best matches each given situation and to explain your reasoning. Now, I'm not going to explain the reasoning. What I'm going to do is we're going to go through and annotate the problem, and then you need to, I'll tell you when to pause, but you need to pause and see if you can pick the one that matches best. You do not have to write down the reasoning yet. I want you to pick the one you think matches best, and then I'll unpause the video, show you the answer. I'll have the thing that you should copy down for the reasoning. But let's annotate and do our reading annotation strategy first, okay? So number 1. The garden club is planting fruit trees in their school's garden. There's one large tree that needs 5 pounds of fertilizer, and the rest are newly planted trees that need half a pound of fertilizer each. So annotating or underlining, I'm seeing that this part where it says there's one large tree that needs 5 pounds of fertilizer. The rest, I think that's our variable x, because it doesn't tell us how many. That's just the rest of them are newly planted trees that need half a pound of fertilizer each. I think we can cross out this whole first sentence. It doesn't, I mean, it's good to know that we're talking about a garden club, but to match it up to the inequality, we don't need that part. So that's the main thing I would cross out. The rest of it, I think we're good. So pause it here. Talk with your partner. Think on your own. Use your best thinking strategies. I mean, we can annotate more. This is just a 1. This that's a 5 here. There's not much more to annotate. Here's the inequalities. Pause, talk with your partner, pick the one that you think fits best. Pause it now. Okay, welcome back, mathematicians. The answer for number 1 is B. And here's the explanation that you should copy down. Let's talk it through real quick, and then I'll tell you to pause, and you can copy it down. They say the answer is B because half a pound for each unknown number of trees. That was this thing of like the rest of them. The unknown for each of an unknown number of trees plus the 5 pounds of fertilizer is less than or equal to 25, which is likely the maximum amount of fertilizer that they have. So if we think about this in the real world, they're planting trees, they got some fertilizer, they know their big tree needs 5, and they only have got 25 pounds of fertilizer in total. So all the rest of however many number of trees they can plant that each take half a pound each have to use the remaining amount of fertilizer. I guess that would mean they'd have 20. Well, half of each has to be less than 20 pounds, because after you take the 5 from the one tree, you only got 20 pounds left. Okay, you should have this explanation copied down. I'm going to pause the video. When we come back, we'll go to number 2. Okay, number 2, mathematicians. The chemistry club is experimenting with different mixtures of water with a certain chemical, sodium polycrylate, to make fake snow. Cool. To make each mixture, the students start with some amount of water and then add 1/7 of that amount of the chemical, and then 9 more grams of the chemical. The chemical is expensive, so there can't be more than a certain number of grams of the chemical in one mixture. Well, I don't think we really need even this whole first sentence, but to make each mixture, the students start with some amount of water, that's our variable, and then add 1/7 of that amount of the chemical, and then 9 more, that means adding again, and it's expensive, so there can't be more than, that means there has to be less. If there can't be more than, then that means less than, right? Okay, I don't think we need this first sentence. I'm going to cross it out. We don't need all this extra words. Look at what's left, okay? Look at what's left over. It's expensive, that's fine, but look, okay. Adding 1/7, adding 9, less than a certain number. Okay, talk with your partner, see if you can agree on which one. Pause the video,